All right, take it away.
All right, thanks very much. This talk is about intake, which lots of you will have at least heard of or used. And really, I'm hoping for feedback. That's the reason that I've come today, is to get your opinions on what I've been doing, whether it's good, bad, or indifferent. Briefly about me, you've seen me around for a long time. I used to be a scientist, so those of you that are strictly scientists rather than software people, I've been in that world, and this is my favorite little animation of the Villa pulsar from my past. This is in X-rays, and it's sort of corkscrewing. If you can see that on your screens, I think it's really cool. But more recently, I've been making software libraries, and many of them are used by Pangeo and PyData in general. Particularly, we've talked a lot about FSpec and Kajunk, but I'm involved in some of these other things too, and particularly intake has actually been around for quite a long time. So intake is a Python library, and it's about declaring datasets. So you can describe what a dataset it is, what it's for, how you load it, and you can organize these declarations into catalogs so that you can find your data and point other people to how to get that data without them needing to know a lot of the nitty-gritty about what specific sets of parameters you might need. That's the sort of background for intake. And as I say, it's been around for a while. It gets used by some people. And this phrase here, load the data and get out of the way, was how it was designed. So intake is just the loading layer, intake one, that is, with some extra convenience and functionality thrown in for fun, and ways of making catalogs out of third-party services. That's quite important, particularly here, and we can talk about that later. The idea that you can have your catalog described by stack, for example, or something else, but you can view it as an intake catalog so that all of your data sources have the same API, the same field, the same way that you use them. So, questions for the audience. Do we actually need intake? There are other things in this space that do some of this work, particularly Kedro we can talk about is one that I think is really quite mature and does a lot of the things right. It's not the only one. There are lots of different tools that do some part of this job. Kedro has this weird thing of being tied to a project model. So each of your datasets lives within a particular project. They're not entities in their own right, which is a bit weird, but that's how they've decided to do it. So other questions, is intake fine? Does it do everything that you need from intake, or is the thing that I am trying to do here, what I'm going to present, is it going in the right direction? If I'm going to go ahead with it, and that is an if, then what things do I need to concentrate on getting right? So I'm hoping for your feedback. Okay, intake as it is has a bunch of drivers. There's this page that lists them all. Some of these get downloaded regularly. Some of them are seriously old and out of date. Download numbers are pretty small. Doc hits are pretty small. But I know intake gets used by corporations. It's just that corporations that use intake internally don't get to tell me about it because it's their own particular data lakes, it's their own particular systems. And a lot of the intake users, if they're out there, are actually invisible to me. So I come to Pangeo because I know you guys and I know that you know what intake is. So that's great. If intake is to become a thing that's known more widely in the Python data sphere, or some things have to come together. And this has been true for the many years that intake has been around now. You need to have users that have access to lots of data sets, and those data sets of various different types. That's when intake was really useful, by providing a layer over all of the different things and all of the different types of things. You also need catalogs to exist. Otherwise, nobody's going to realize what intake is for if those catalogs don't already exist, so they can see how do you go about using intake. So we have an adoption problem. You put these things together. And then finally, if you have interesting other catalogs that you want to unify under intake, then you need developer effort. Developers not going to put that effort in unless we have users that are interested in using intake. But if they do, then suddenly we have a lot of catalogs that intake has access to, and then you can get the users. So we have a real chicken and egg kind of hurdle there, and that has prevented intake from taking off for a long time. Interestingly, one of the main things that I found is holding intake back is that if you have to have catalogs that exist, you have to be able to make catalogs, and making catalogs is actually harder than it should be. And there could be convenience around this. There are some convenience functions around this, but it's still tricky. This was an issue from yesterday. You can write drivers. It's hard to get right, especially when those drivers are for catalogs. But even if you have all those things in place, often making a catalog involves writing YAML, and nobody wants to do that. Okay, so I decided to go ahead and rewrite things. Why did this happen? A big part of the motivation came because of Anaconda Cloud, which I don't know if people here have heard of even or ever used, but it exists. It has one single example intake catalog built in. And this was released with great fanfare back in February or so. And there was all this chatter around, okay, so we want catalogs to be a thing. We want people to be able to make catalogs. So we're going to have some website UI thing to do that. This did not come from me, by the way. And the only mockup that I saw of this was hey, I have a single URL and it's going to point to a CSV. Because that's a simple case, it's a relatively useful case. But if that's your only case, then you don't really need a catalog. But if you have something more complicated than that, and you do need a catalog, then building a UI around it for how do you make this catalog is really difficult. So I started to think around, what can intake do to make this process easier to onboard people into the idea of catalogs in the first place? And it comes down to readers are too complicated. We have a lot of classes. Understanding the differences between them is hard. And throughout the code base, there's all this stuff around Dask and other things that seemed like a good idea 5 years ago, but maybe are not the only ideas that are around, let's say, and it doesn't need to be built in from the start. This, by the way, is the Anaconda data catalogs. I could probably launch a poll, but I'm not going to. I'm wondering if anybody here has seen this at all. You can comment if you like. Let me, I should be able to open up the chat thing so I can see comments as they come in. Feel free to comment there. Okay, so this was back in February, and then from March, I finally got my new colleague in my group, the DisDataCats group at Anaconda, who was going to train on intake and then start actually doing something with it. And this colleague of mine did 11 PRs to existing intake to understand what it was and did some contract work. And I started the rewrite in May. Unfortunately, that coincided with the internal reorganization of Anaconda, in which this particular colleague of mine was reassigned from the group, and I myself was partly reassigned to another group too, which has meant that since I started the rewrite and now I've had a tiny fraction of my time to actually do the rewrite, and it's now at a place where I can present it to you and get your feedback. So that's the reason it's taken longer than I had thought it would do. Okay, so there is a descriptive doc, which is sort of a version of this talk. So you can read that if you like. It has some more details, but it's slightly out of date because I have been trying to push this ahead. And there is the PR itself, which is now very long. It's still in whip phase. Thank you for the poll. But people are welcome to have a look at that. Okay, so what have I done? I've removed a bunch of stuff that nobody used, including the server, the caching system, the command line interface, the persist, the conda package templates, the pattern matching catalog, the HV plot magic, direct dependence on Dask, and all of the extra packages that come along with intake are being consolidated. They don't have to be in one package, but this made my development life easier. So I removed thousands and thousands of lines, and then I started to write thousands of lines. So what have I added? And these are quite fundamentally different from what has been before, and I'll demonstrate them in a moment. Now we have pipelines. Before we had derived datasets, which were very clunky add-on after the fact and really difficult to use. Now we have full pipelines in which you can describe, I'm going to load a thing, I'm going to do this thing to it, this thing to it, this thing to it, here's the output. Or I'm going to branch. I'm going to do this thing or this thing the same as before, and I'm going to do something else to it, this thing, this thing, this thing. But these things depend on one another in a way that you can describe in a graph-like way within a catalog itself. The idea is that you can describe, just loading a thing isn't usually not where you start your analysis. You want the thing that you actually want, right? You want to get from a thing on disk to the version of the dataset that is ready for you to do things with. And that's what the pipelines are about. Maybe you actually want a processing pipeline, like the sort of prefect thing or something like that, where you go from beginning to end and you want to encode all of this thing. There's no reason that intake shouldn't be able to do that. Now everything is in place to enable it. There's a recommendation system. I'll demonstrate this, where you can say, I have this type of data. I want to get it into this kind of format. I want to transform it, not manipulate it. How do I do that? How do I go from this kind of data to this kind of other instance in memory, or perhaps this other file type? And since intake now has a whole bunch of converters to do it, you can guess what's the best way to doing that, or get you a list of ways of getting from A to B, and you can pick one. This means, oh, nice typo in the middle there, sorry about that. We're not just depending on Dask. We're going to have, for data frames, sure, Dask handles data frames, so does pandas, and this was part of the original scheme, but so does DuckDB, so does Spark, so does Ray. There's Modin, and I don't know, Vakes, and all these other things. You can do it in polars, and they all do the same things, more or less, with slightly different API. There's no reason that we should be limiting ourselves just to Dask and pandas. And some more parameters stuff, which if you already know intake parameters, they are now more flexible. But we can get to that. I aim for compatibility. So the CSV source, the intake-1 CSV source in the PR now looks like this. It's the only one that I've explicitly rewritten. And it now just calls the stuff in the new code base, so that old sources should continue to work, at least for most of them. Some options are missing, and these are the options that weren't really being used by anybody, such as the pattern matching stuff if you have a bunch of CSV files. But everything is done here. You can see Discover now depends only on pandas, because whether you're using pandas or whether you're using Dask for just getting the head of your data was one of those many ambiguities. So now we just use pandas for that. To Dask makes it a Dask thing. Just read makes it a pandas thing. That was the implicit thing, the implicit idea before. And we have Spark here. This, by the way, this proliferation of .2 things was one of the things that really annoyed me. And there was no real way of discovering which types of data could become which types of thing. Okay, I'm going to switch over to my demo. I'm rushing through this so that you can see as many of the ideas as possible. And again, the kind of idea here was, how do we get people into intake land? And here is a way that a data scientist might previously have referred to their data. Here's my read line. I've added in some storage options which you don't actually need here, just to show that you can. And here's one of the fancy guess what I did calls, which looks at the text of that previous cell. And you can just paste the text in here if you like, and it tries to deconstruct it. It sees that there is a URL there that looks like a CSV, so it makes a CSV data thing, which is this. Or we have it again here because the reader depends on that, and it guesses that we did pandas.read CSV. We recognize this as being the pandas CSV reader, which is not too surprising, but we can do this automatically. And we can do this for quite a lot of different inputs. So if we we get the reader instance, and out of here, we can do .discover on it, which is the same method as before. And now it using this encoding here, it now basically calls the same function as you had before, but now it's encoded in the intake way. So you can make your definition of what the data is just by looking at your existing code. You don't have to do the intake.opencsv and know that that's a pandas way of doing things. So you're going to have to look at the pandas documentation to find out what are all the right keyword arguments that you need there. We also have entries. Those the entries and readers are kind of the same thing. The entry is the long-winded dictionary-like description of the reader appropriate for putting in a catalog. I may go back and unify these two things. They're kind of the same thing, but an entry can have parameterized things within it, whereas a reader is the concrete version of it. They're kind of the same thing. I have this data instance too, and I can say, what can I do with this data instance? What are its possible readers? For CSV, we can read it with pandas, geopandas, ray, duck, dask, and the file. This is ordered, by the way, so CSV specific things come first, but any file can be read by the file reader because that just produces bytes. I don't happen to have Spark in this environment, so it's showing me I could have read this with Spark if it was installed. Also, I can do things to the reader. So here are all the known transforms for a reader. I can produce a geo data frame if I call the pandas to geopandas function. We don't know if this particular data frame is appropriate for that, but it's something you could conceivably do. I can also turn it to an HV plot if I call to HV plot, and that will create one of these hello views objects. And I can do other things as pandas to CSV. Actually, I can write this out to CSV. Pandas to feather, I can write it to feather, to HDF5, to parquet. Those are all the things that I can do to a pandas data frame. I can even do .to matplotlib, and that will just call .plot and produce whatever that does. I have all of these as methods on the transform object. And I have all of these also appear as methods on the reader itself. So the transform is a convenient way of displaying what things I have available, but actually I have them directly on the reader. I just don't know what they do without looking at their documentation. So I can call these transform things in a chain, make a pipeline. In this pipeline, I've taken my original reader of CSVs to pandas, and I'm going to say, I'm going to select some columns. I'm going to call a method where the method is called setIndex with this keyword argument and do to HV plot. That's kind of long-winded, but the point is that at each point I can call .transform to investigate what things I can do to the instance that I expect to get. But this is all lazy. Nothing is evaluated. If I call .read, I go through my pipeline and I evaluate each of these things and get this very nondescript graph out because I haven't actually set any keywords here to customize this. There's some data in there that I can't see. A quicker way of doing the same thing, I know this is going to be pandas, so I can use pandas syntax to select the columns. I can just call the method directly on this, and I can call this to hvplot if I happen to know that's what I need. And this does exactly the same thing as what I had before, but now in a much more condensed form. Okay, I also have recommend functions. So I had this is the same as before. I had the what possible readers do I have? So this is exactly the same. But I can recommend with some information. So if I say, I know I'm going to want a reader that does something with Ray, I can do that just by, there's a regex thing going on to match this to the various things. This is what it's going to match with, as it happens, the name of this transformer. I can transform that too in turn. I can go down the class list and look at all the things I could do. I can transform my rethink to pandas. I can make that into the same HV thing. Now I can add a keyword here because I know that I'm doing a hello user thing. But now it's Ray that's doing the reading. Ray is reading this. It's giving me back the same pandas data frame, and I'm giving this to the hello views explorer. And this thing, up until read, this is again a pipeline. I can put this into a catalog. And there's some more examples of this. I can I can read the Dask data frame using Ray if I really want to. And here are all the things I could do to the Ray. Like, you get the idea. I could turn this into a Dask data frame and then turn that back into Parquet. So now Ray is doing some reading and giving it to Dask, who's going to write it back out to Parquet. Okay, it's kind of silly example. So I'll skip over that bit and show you the X-ray part. So that was the standard demo that I had for non-Pangeo people. You can do the same with X-ray. Here's my open dataset call on some grib thing. My only argument here is the chunks. So I'm going to, this is like silently using Dask, which we understand how to do. I can do the same thing here. I make it into a reader instance. It's grab this chunks equals argument and put it there. I can get the reader. What can I do to an X-ray dataset? A whole bunch of things. This is not filled out, by the way. There's a lot of more functionality, conversions and all that I will get to. Interestingly, though, I can get directly for each of these transformers, I can get the documentation, which is good. So I know what keyword arguments actually make sense in the X-ray to ZAR is obviously the .to_ZAR function or method, which means that I know how to call this. There's a mode equals X thing. This gives me back another data instance with which I can then again load it with X-ray. So this is how you have a pipeline in which I'm actually doing caching effectively, which means aside from FS spec level caching, I can explicitly build out a caching pipeline if I want to. And there is even a condition node which allows me to say I can take the versions of from the file if they happen to exist. If they don't happen to exist, I can run the pipeline and make that file so that I can read it from the file. Okay. Oh, and I can do hollow views on that thing too, which shouldn't surprise you. But I'm not going to run that because this actually takes a while to render. I have a second tab. How are we doing for time? I'm running short. We started at about 5 past. Now we have some catalogs. I can put these reader things into catalogs. And this is like, I can build catalogs really easily now. A catalog has this named thing. It also has a bunch of entries. For the time being, these entries have sort of opaque tokens, so I don't have to give things names. I also have data. So this is the description of the basic data, which is this CSV thing. But the same API is maintained. I can do catalog.namedthing.discover or read. And there's my discover is just a head. I can call the functions on this as I had before to make this reader 3 is now a pipeline. It's calling pandas.describe. And I can add this entry without a name, and it just appears as one of these. Is that the describe one? Yes, describe. Obviously, the repr here leaves a lot to be desired. So there's a lot of prettifying that can be done, but this lends itself to an HTML view. I can name things. Now I give this thing a name, and then I can call .describe.read, and there's the describe on the data frame. But there's only one entry in the data because they both depend on the same data, which means that I can call this data to, I can do things with this data, such as decide what reader that I'm going to do. It's still there in the catalog. I have access to it if I decide I want to read it with Dask instead of with pandas. That's fine. Interestingly, now I can put things into catalog that depend on multiple upstream. So we have a reader. I'm going to call a method on it, but in here, I'm going to also have that the argument is, actually it happens the same reader. It could be any other of my readers. They all get added to the catalog. So I can have join and things that depend on multiple inputs. So if this is the pipeline, and it depends on this other reader, which when I instantiate it effectively, I make a pipeline by calling this. Everything is embedded in here, and I can do read on this. Does this Does this data set equal itself? It does. Good. In the next one, I'll show you how you can actually save these things. So I won't belabor the point there too much. One of the major things that I've retained, so this is the same start exactly as we had before. We have the reader, and I'm going to put it into a catalog, but I can also extract some parameters from it. I can extract as the parameter named index key all of the things that have the value this string, which means that my entry can have some user parameters, and I've given this a name. It's a simple user parameter. I can edit this thing in place if I want to. Again, this lends itself to a GUI kind of workflow. And this has replaced the value, actually a couple of values. This is an example, if we have the time to go into it, of something that was done incorrectly. It replaced both the column selection and the index selection because the same string appeared multiple places in this definition. But I don't need to belabor that. The point is that there's multiple ways of doing this. So I can also go into my arguments and select a particular field using this kind of syntax and say, okay, before I replaced all values that happen to equal this thing, now I know that I want to replace this particular location within my structure. So when I do this, I get I again get this user parameter, but now it's only replaced to this one and not this one. You can manipulate these user parameters, and they can be at the catalog level, at the data level, and all of the readers that depend on that data thing, or at the reader level that it only applies to that specific encoding of the reader. So if I only want the pandas version of the CSV reader to have user parameters, I can do that. But much of the same stuff is retained as previously. So these things, you can see it's like this. This will get refilled in when I actually access this, but I can update the value like this. So I can say for this value, this index key parameter, I actually want to have it this value, and now it's been replaced over here. Okay, I'm going to skip over some of this. I can put things into a catalog as I described, and I can do this user parameter stuff within a catalog where, again, we've retained the environment values, which is going to be templated into here. Now we have a wider set of things that I can add into here. I can add full anything that I can serialize as JSON essentially becomes a possible parameter value. And I can I can change these things in place so that I can have this default and this prefix, and I'm going to reconstitute this thing when I actually want to do the reading, but I could have changed those values. So skipping over these things, we can also write this. We can still write to YAML, obviously. That's going to be the default serialization. But the idea is that I don't really expect people to directly edit this, except maybe descriptions if you really want to. I don't want people to edit YAML as the principal way in which they're going to create their catalogs. It should be possible to do this directly. Okay, so that works. We have access to some namespaces so that if we know what type we're going to operate on, an XRay has its own namespace, then those helper functions are in place. That's the demo. So I'm going to whip through the remainder of my slides just quickly. This is the current state of all of the data types, the readers and converters. There's quite a lot of them, and I am nowhere near ready filling out this space. There's loads to be added, but adding these things is now really simple. I just have to put in the work. I even have some catalog readers available. So these are rewrites of existing intake one sources. So there's threads catalog reader, stack catalog reader, tiled catalog reader, and SQL tables. And with stack and tiled, you can do queries, and it directly it does what you would expect if you know anything about the third-party package that's being called. And there's reference to these compute engines, and there are more to add. this is for anybody that's ever heard of Odo, which is now ancient, but was kind of great at what it did. This is starting to look like that, except because we depend on FS spec, we don't need to worry so much about where things are stored. All of that stuff is handled directly. There's lots of stuff to do. I want to enable all intake one sources. They should still work. I want to have a straightforward way of adding things. And that will be a simple part to do. Fill out all the types, make nicer repos so that you can actually see what's going on instead of all of those nested dictionaries. Example, interesting pipelines like the cache thing that I talked about should be there. Open question about whether readers and transformers of pipelines are really different things or whether they should be the same thing. And of course, there's existing intake things, which like the stack and threads, they should be easy to port. It just takes some time. And then put this out there for the world if people like it. So the questions for today, this is the same as the previous slide, and I'll leave it here. Does anybody actually want intake as a thing? If it existed with all these things, would it be useful? Or perhaps it's already useful and you don't want it to change. I'll leave it there and open it for discussion.
All right. Awesome, Martin. Thank you so much. Stop the recording.